Hey friends, I am starting a new video series to help blockchain analysts like yourself and take your analytics game to the next level. My name is Sam, I'm a data curator. I create models to best represent events such as NFT sales. For the first video in this series, I'm going to share my thought process as I go through a new protocol. So a few days ago, or rather last week, I saw 0x NGMI, or the person behind DeFi Llama. They posted a tweet saying or promoting this new marketplace, NFT marketplace called Seal Art. And it turns out it is a marketplace created by them. So I thought, hey, why not create a video to showcase how you can analyze this protocol. So first thing I did, click into Seal Art's Twitter, and then of course try to read what they're tweeting to get a bit of context what this NFT marketplace is about, how it differs from other marketplaces. So I already did a bit of reading. So I read their docs. You can just search, Seal Art docs and go through the docs. If I were to summarize, it's a new marketplace where it uses a Victory auction, and essentially it's a system where anyone can place a bid on listed NFTs, but all the bids are invisible. And by the end of the auction, the person with the highest bid is the winner. But the difference here is that they only pay the amount of the second highest bid. So the rationale behind this is that as you can see here, right? It's a sealed bid auction where bidders submit their bids without knowing the bids of others, and the highest bidder wins but pays the price of the second highest bid. So I thought this is interesting, and yeah, let's look right into it. So looking at the website, first thing I want to know is how can I get the contract address, or like how do I find a past sales transaction? And scrolling through the website, I see a recently sold, this panel. Click on click on one, for example, and then it's nice that this site has already listed the list of events leading up to the sale. So I see a minted auction created, right? But I also see it says foundation over here, which I'm assuming is the foundation marketplace. But we are only interested in this, or we're only interested in transactions related to Seal Art. And so I see auction created. I'm going to click on that. That leads me to Etherscan, and I'm just going to click on bought by. So I have auction created, but it says here change auction. Okay, so let's click on the other one. And okay, so looking at Etherscan, you can scroll down to the call data or input data and sort of see what is the function name, or like the main function name. In this case, it's create auction. And then if you notice, there's another auction created 2 days after the first auction. And when I click on that, it tells me change auction. So this tells me that the NFT owner, change some details of the auction, be it the auction type or reserve price, etc. But I would assume change auction wouldn't matter to us unless you want to track all of the possible auctions created. So there will be so if that's something you're looking for, you will also need to account for, change auction. And last but not least, we have, this is the buying transaction, right? Bought by. If I scroll down to the call data, the function name is settle auction. So this tells me that at the end of the auction, someone would have to settle the auction, which means pay the bidder gets, which means the NFT seller gets the ETH, and the NFT buyer, or the winner of the auction, gets the NFT, right? So in this case, just by looking at Etherscan, this address interacts with the seal. I can just click on it. It's labeled as seal art market, so I'm guessing this is the main marketplace contract. So this address interacted with this the seal art marketplace called the settle auction function, and received. So this address did not receive the NFT, but instead they receive the proceeds from the auction. So this must be the NFT seller or the address that started the auction, and the winner of the auction would be this address, B61 over here, because they receive the NFT. And this also tells me that it looks like Seal Art uses their form of ETH, kind of like Blur uses their form of Blur ETH. And so it's sending to the null address because it's burning Seal ETH to get back your native ETH and sends it to the appropriate addresses. So we have several addresses here. There is the this address, which is the same as this, and which is the same as the sender. So, and then we have a third address, or rather the second address, where it's a safe address. So I'm gonna assume that this is a platform fee address or platform fee receiver address, because while I was reading through the documentation, it did say that they charge a 2% fee for the sale price. So let's just quickly validate that, right? So we have 0.0616 plus 0.07 plus 0.014, and I get 0.07 times 2%, and indeed this matches this figure, which most likely this is the platform fee receiver. Also, this is the platform fee amount, right? So that's that. What else? So next thing I would do is I want to know what information is emitted in the logs, and if we can find useful information that we can use. So transfer events, not that useful. Save receive, not that useful. Auction settled is useful because that's the event that we are looking for. Unfortunately, there are no useful, or like there are no much data that is emitted through this event. We only have the auction ID. So unfortunately that means, or fortunately if you like traces, that means we will have to look into traces to be able to get all the details from the auction settled. Or you can use the transactions table input data, which should be this. So let's try to verify if this is the same as traces. So what I like to do is I like to go to this site called Tenderly, right? Click on their Explorer and then search the transaction hash. It takes a while. There you go, mainnet, Ethereum mainnet. So what I'm looking for is if the seal art market contract, if there is a proxy address, and you will know if it's a proxy address if there's a delegate call, which means it calls the code from another contract. Looks like there aren't any delegate calls from this marketplace. It looks like the marketplace itself uses the code on this contract. And yeah, so you want to scroll right, and to do that you just simply click this button here to minimize. And so I see there's NFT owner, NFT contract, auction type, NFT ID, reserve, bid. So this looks very similar to the call data from transactions. NFT owner, NFT contract, auction type, NFT ID, right? And I guess what we're interested in is we want to get all the sales or the list of sales, which means we want to find all the events that are related to settle auction, right? And so the information that will be useful would definitely be the NFT address, which is NFT contract, NFT ID, NFT owner for sure, bid winner. There you go, bid winner address. So who won the bid and would ultimately receive the NFT. Bid winner amount, 7. Let's verify that. So I recall earlier that when we did our calculator, it was 0.07. So the value here, I'm assuming, would represent the amount, the second highest bid, right? Because the winner's bid, or the winner who placed the highest bid will only pay up to the second highest bid amount. And then we have auction ID, which I guess correlates to the event logs over here. Auction ID 241. You should also see 241. There you go. Okay. Yeah, so from what I'm seeing so far, it seems like we can use the traces data to extract all the information that we want, instead of logs. So let's before that, I just want to make sure, I just want to know if settle auction is the only way of settling the auction. So I would go to the contract itself, like so. Click on contract, and then sort of eyeball and check for settle auction. Okay, so this is settle auction. I see there's a settle auction with sealed bids. And I guess another way of settling the auction. Yeah, I think that's all. Yep, that is all. Okay, so there are two ways of settling auction, which we should consider when dealing with traces. So let's first start by looking up this transaction on traces and see what we get. This is December 1st. So I've created a blank query here. So select all from ethereum.core.effect traces. Block timestamp is December 1st, so 12:01. Okay, so I'm gonna order this by trace index ascending so that I know the order. And in the traces table, there's always a call origin. In this case, we will want this call origin. But there are cases where we do not want this call origin, especially if the contract uses a proxy where we would use delegate calls instead. So recall earlier that sealed art market is this contract over here to CBE. And so this is the exact trace that we want, where the address initiated the interaction with the seal art market contract, and we want this exact input. Okay, so the way I'll filter that is, I would say n2 address equals to this, which is the seal art market contract, right? What's relevant to me would be transaction hash. I guess from address to address. Why not? But and I have a piece of code over here that I already assume I'm going to use. It's a So what this code does is it takes input, which is over here, starts from the 11th character onwards, and chunks it into 64 characters, right? And the reason for that is because how call data is arranged. See this big chunk over here. I'm just gonna paste right here. Oh, that does not look good when I paste. Okay, we'll just work with this. So the first 10 characters is actually the first 10 characters of the we call it the function signature. It's essentially the cat check of the event name and all of these variable types. So for example, if we go back to the settle auction contract, we would see here the variable types, right? Or maybe it's easier if I go to this over here. Etherscan already has it for you, where it says, settle auction, and all these are the variable types. So a cool thing that you can do if you want to verify this is, or if you want to see how this is derived, you can go to this utils called catcheck. So select live query.utils. Utils, okay. And then you paste whatever that you've gotten from Etherscan. And this is an important step. Remove all the spaces. So remove spaces. Yep. And before we run this query, I'm just gonna copy this as a reference, right? So let's run this query, and it'll take let's let it run. Essentially, it's taking the function name, including all of its variable types, or the variable types of the inputs, and applying this catcheck function. You would get this long I guess hash over here, and see how this matches this over here, right? So essentially a function it's called a function signature, where it just takes the first 10 characters of this. So call data structure would look something like, the first one will be, the first 10 will be function signature, and then, address, bytes 32, and all of this would have a length of 64 characters. which is why in our select column over here, we have this regex expression to uh, take input from the 11th character onwards, because that's where this thing starts, and cuts it into parts of 64 characters long, right? Yeah. So I'm gonna comment this out. Go back to this, and we will see what this segmented data looks like. All right. So segmented data, you will notice that it is now an array of 64 characters long. And how do you know what does this represent, right? The way to do that is to again refer to tenderly, or refer to your contract, right? We know um, the first thing here would be an address, right? An address. So let's focus on this one, 4CE. And if we go back to tenderly, we see that 4CE is the NFT owner, right? So you can see how all this is in laid out nicely, similar to how it's all laid out in this segmented data over here. Now, the only caveat that I want to say to this is we're able to do this because there are no dynamic variables, which means how do I say this? Which means every information is represented consecutively. A dynamic variable will look something like this, where it says it has an array here, right? This would then be a dynamic variable, and the additional stuff you have to deal with dynamic variables is that instead of just the data here, which is what you want, it first tells you the position of the data, and then you have to go to that position to get the actual data that you want. So that's the only difference. But luckily for us, thank you to the DeFi Llama gods, there are no dynamic variables here. Okay, so let's move on. So we know the first one is NFT owner based on Tenderly. Second one is contract. So let's see, 8DD. 8DD, right? So all these are very nice. We just have to map all this information back to what we see on Tenderly. Now, I like to just gonna copy this. I like to use a site called Code Beautify. It's just a JSON viewer. Paste your array of segmented data, right? And it spits out nicely for you, what position is the what positions the positions correlated to the actual data that you want, right? So how you would write this in code in SQL is, for example, segmented data 0, and then cast it a string. Call this as NFT owner. And if I run this, you would see that it is not quite, you know what, I'll just do this so that it appears first. If I run this code, you would see that NFT owner appears like so, where there are leading zeros or trailing zeros. I guess leading. And it's not exactly the address we want, right? Because the address we want starts with 0x and then 4CE, whereas this is like, there's a bunch of zeros here. So we would apply a substring. So substring this whole thing, and I only want the 25th character onwards. Let's see if that is correct. Oh, my bad. I guess I cannot escape from pulling this first. I guess I can. So let me just make a subquery. So with raw as select Alright, amazing. Right, so we have 4 CE, which means 25 is correct. You would just have to, for addresses it's always 25. But yeah, 4 CE. And to get 0x, you would just have to concatenate this with 0x in front. So you can do like so, and then do this sign. Where is it? I can't find the sign. Is it? Oh, there you go. Okay. So this means concatenate. So concatenate 0x with all this, and this gives us an FD owner, right? We know the second variable is an address as well, right? From here, so we can apply the same thing, but instead of 0, we just do 1 because it's the um, second variable in the second index in the array. And instead of NFT owner, this would then be NFT contract, which is the NFT address. Alright, we're making progress. So just to show you what it looks like. Nice. Continue doing so. So auction type, I'm not sure what we can do with this. But I think we'll move on. We'll skip this, move to NFT ID. Now, NFT ID is a bit different because it's a bytes 32 data, and so it's not really we don't really have to use substring, right? Maybe let's see what exactly it is, right? So segmented data 3, because we're skipping 2. Let's just see what it looks like. It looks like this, right? And for bytes 32, we have to convert this to an from hex to integer. We have a function for that, so you can use something called utils. Is it called utils? Yeah, there you go. It's this function over here. So UDF underscore hex to int. Because it's a token ID, I just like to cast it again as string to prevent any issues. And let's call this as token ID. Can run that just to make sure. Next one we have first we have bit, and this is the public signature or CDSA signature. Not that interested. Auction ID, potentially interested if you want to join if you have event logs, but in this case we don't have to. What's interesting to us is the bid winner portion, where we have amount and winner. So first we find where is winner in our data, right? So winner is B618, and it's the last variable. So it should be the last in this array. Yeah, there you go, B618. B618. Yep, that's the one. And the one before that should be the amount, right? Again, this is hex. We have to convert this to an integer. To quickly check, you can also use, I like to just Google hex to int and use the first website that pops up. Paste your hex value here, convert. You will get, 7 and zeros, which is what we see over here. So we are going to replicate that array index 14. But because it's the amount, you can just say amount paid, right? And because we know this is always going to be paid in seal ETH, right? Or Ether. It's always going to be 10 to the power of divided by 18 decimal places. And we can just do divided by 1e18. Excuse me. Or just, 10 to the power of 18 like this. So same thing. And then last but not least, we have our address, array 15. Because it's an address, we again apply the substring method over here. So just copy, paste, and array index 15. Amount paid is 14. I don't know why I wrote 12 over here, but it's 14. Let's see. I think that's it. Oh, did I write something? Oh, I forgot to change the variable. This should be the bit winner address. There you go. Okay. So what we just did is, just to recap, we looked at traces. We verified that the sealed art market is not using a proxy address, right? Because if we expand this, there is no delegate calls from the sealed art market. And also, you can see the function is here directly, right? Settle auction. And so we're using this particular trace. We use the contract address itself to come up with the function signature. And we also verified that, there is no dynamic dynamic variables here, which means we're able to just use this method of arrays directly. And let's see what we get, right? So if I scroll past all this, there we have NFT owner, right? The one who created the auction. NFT address of the auction, of the NFT address that is, auctioned. Token ID, amount paid in ETH, and the bid winner's address, right? If you want to go a step further, you can just multiply your amount paid with 2% as the platform fees. Why not, right? So 0.02 times amount paid as platform fees. And then, just for information's sake, I'm just gonna write ETH as the currency address. But yeah, pretty straightforward way to analyze the sealed art market. Now, I do know that there is another settle auction over here, and maybe you can do your own analysis for settle auction. But I'll show you a quick method of how you can get example transaction hashes for this function. So let's go back to our query. Alright, it's all good. Let's go back to our query. Let's copy this raw section over here. Make a new query. And I'm going to filter function signatures that are sent, or like I'm going to filter by functions that are called by the seal art market. Okay, there you go. So the way to do that is so recall earlier how function signature is the first 10 characters. Oops, what did I press? So I would just need to put, input 10. This gives me the function signatures. Call it function sig. I don't need the rest. Do a count 1. Yeah, this is fine. And then to address is my seal. Group by 1 or just group by function sig. And this will return me a list of function signatures as well as how many as well as how many of them are called, right? But I can do one step further and say, after knowing the function signature, I have to know the transaction hashes anyway. So I'm gonna remove the count, and I'm just gonna do a qualify. So something like qualify row number, partition by, I'm not partitioning by hashes because I just want one sample transaction hash per function signature, right? Order by, this block timestamp descending to the latest function, or rather latest transaction per function, and yeah, so they should tell me to give me a list of all functions and a sample transaction, so I can look at sample transactions. I'm just gonna call this sample transaction hashes for this functions in. Okay, so let's see the first one. So the first one is, it looks like, okay, so the first one is create auction, right? So what you can do is you can, oops. What you can do is you can just make your own personal notes, right? Like this is, create auction, like so. This is how I would do it. This is change auction. This looks like it's deposit, so I'm guessing the person is depositing. Wait. Interesting. Not exactly sure what this means. You would have to dive deeper on that. This looks like settle auction. There you go, settle auction. withdraw. So I guess you withdraw your bid. Then last but not least, this should be settle auction with sealed bids. There you go. That's the one that we were looking for. And yeah, so I'm noticing now that there is a dynamic variable in settle auction with sealed bids. So maybe I can just quickly show you how you can do this. So the first one would be a dynamic variable. So dynamic variables, if you do a hex to int for this data over here, it tells you the position of whatever this thing is. So what is this thing? If we go back to our contract, this is call data salts, right? So the if you do a hex to int of this, it tells you the position of call data salts. So let's do exactly that, right? 544. Now, one thing I forgot to mention is 544. After you do a hex to int, this tells you the number of bytes. So to convert this to position, you will need to divide this by 32, because 64 characters means 32 bytes. I mean, that's how I would understand it. So 544 divided by 32 tells us 17. So the 17th position after this. So let's see. So the 17th position would be 17th position after this would be 18, if that makes sense, right? And the salt data is 5E1D6. So let's look if that is true. How do we look if that is true? We go to Tenderly, paste that transaction. There you have it, 5E1D6. Exactly what is on the data over here, right? The rest of the data should be normal. I don't see any more dynamics over here. Maybe tuple has, I'm not sure. So you might be dealing with maybe not, yeah. Not sure. But anyway, that's how I would analyze a new protocol. I checked if the event logs had any useful information. In this case, it did not. So we would have to rely on traces. And this is how you would use traces, right? This gets you the raw data, tells you the list of entity owners, how much was the actual bid amount that is paid to the NFT seller, which address won the NFT, and yeah, the NFT address itself. So with this raw data at hand, you can then create your own further analysis, like summing the amount paid or summing the platform fees, so on and so forth. That's it for my first series. Thanks for watching, and I'll catch you in the next one. Ciao.